Yeah, good morning, everyone. Welcome back to our online class. Yesterday, we discussed about two exploration of a groundwater with using of different geophysical methods. That is resistivity surveys, magnetic surveys, radiometric surveys, and ERT, electrical resistivity topography. All these methods they conclude in the formation of the rock types which are having the resistance. The resistance, if it has a high resistance, it is known as a hard rock terrain was formed in subsurface. If they have a low resistivity, if they have a showing the low resistivity, those formations are having the water bodies or weathered material. Now today we are going to discussing about the quality of groundwater, quality of a groundwater. In this section, we are going to discussing about surface dissolved constants. Those are the physical parameters, chemical parameters, biological parameters, environmental problems. It's sorry, it is related to the human health, irrigation lands, industrial sector, and treatment of a groundwater. Yes, we know that water it is a very important component and it's playing a very important role in our daily life, whether we're using in a drinking purpose or we can use in a agriculture purpose, industrial purpose. Yeah, which the water it's a excellent solvent and it's containing and the lots of dissolved chemical compositions and chemicals. The groundwater it's moves through the rocks. We know that under the earth surface or subsurface of soil, so that it has a lot of dissolved substances when compared with surface water. If it is the ground, if it is excellent and it has depend on the different mechanisms, and when the water it is transporting through this the conduits or through the pores, through the pores, so that it automatically directly it is a natural naturally it is getting the filtering, so we will get a pure water there. And again these underground water also it is getting the contaminator from industrial domestic and agriculture chemicals when it is these are mixed into that water, then it is going to be contaminated. And it is also the chemicals which are inclusion of pesticides, herbicides, and home appliance, whatever it is releasing the wastewater into the surface, and due to the percolation method or directly or indirectly, it is leads to the um, leads to the contamination of the water. Not only that one, based on these contaminates, the common water quality it is going to be damaged. And We face the contamination problems from other septic tanks in such areas in we doesn't have any treatment sewage treatment system or effluent from the septic tank, and these are percolated down to the water table, and it also uh, leads to contamination, groundwater contamination. So that all the groundwater it's contained salts solutions, and it's derived from the from one location to the another location. When they are moving to one place to the another places, it is accumulating, and it's having the different chemical compositions, and it is adding the unwanted material and all those. So these are all the leads to damaging of the original quality, getting the contaminate from these sources. The sources for dissolved constituents. The concentration, there are various types of concentration salts that are present in water. It depends on their environment, the movement and sources of the groundwater. Water quality is changes as it travel through the hydrological cycle, and it is again it reaches to the precipitation to be in the form of a groundwater, and it's have a different parameters, and it's dissolving the different constituents like a physical, chemical, and biological parameters. What are those? Let us see. When you come into the physical parameters, the physical parameters of the water, it is including the color, odor, taste, turbidity, temperature. These are all the physical parameters. And color, uh, it's a color actually. It's looking into the water. It's looking into the normal color. It's blue or actually it is a colorless also. Sometimes we can call, and it occurs due to this is iron compounds, dye and organic matters in your water reported in Hachan units, and odor and taste. These properties are derived from actually it is a dissolved by different glasses or in different glass materials, and it has a like a silica materials, and it's a related again it's a related to the hydrogen gases like H2S, methane, etc., and mineral matters, iron compounds or dyes, and the odor it is expressed. It is a as disagreeable, the earthy and fishy, grassy, mildly peachy, sweetish, and all those mix has a different tastes. The taste it is expressed in a brackish, saline, salty, and the odor and the taste are reported in a different number. But actually, if you can consider these color, taste to um, odor, it's a the water it is also actually without any contamination of this is a water, it is a smell. It doesn't get any smell. Or if it is only mixing of different components in that one, then only we will get the odor. So that based on this we can come to the conclusion. If it is dissolving all other necessary and unnecessary material into the water particles, then only it is leads to the then only it is leads to the contaminate. Turbidity, it is a measure of a suspend and colloidal matters. Yes, definitely. Actually, it is suspend material or suspend matter. If it is any involved or in this, or if it is any suspended matters, it will be involved or mixed or melt in the water. Then the water original quality it is lost. And also not only that one, such as a clay, salt, organic matter, organic carbon dust, and the industrial waste materials, and these all matters if it is melt in the water, or the water if it is if it will meet these substances, then the water quality it is going to be changes. And then we can express this is in milligrams per liter. A temperature, when you come into this as a temperature, the temperature it's different in the different areas. And suppose if you can see the temperature, the at a 4 degrees centigrade, the water it is going to be nearly change into the change into the ice and the snow. And if you go into the minus degree centigrade, yeah, definitely you can say 100% it will go into the or it will be converted into the or change into the ice material. So that, but in a hot season, or roughly if you get the temperature above 30, 40 degrees centigrade, then the water it is going to be slowly it is evaporated. So here the temperature we can found if it is in a polar region and volcanic and tectonic activities regions, then it is different. Such the temperature of the water are not found in the rest of other of the Earth's crust. The changes in the temperature of the water can be helpful in detecting the unsuspected source of a pollution. Um, Next, coming to the chemical parameters. In a chemical parameters, what is happening? We'll see the different parameters. pH, electrical conductivity, it is called EC. TDS, it is called as a total dissolved solids. Uh, pH, that is called as a total hardness. And the total hardness is the classification in the groundwater. Next, pH values, it's depend on the major ions. Like example, for the total iron strength, here calcium, how much it will be present, and magnesium, how much it will be present in that one, sodium, potassium, and all those. And next one, it is carbonates and bicarbonates, chlorides, sulfates, nitrates, chlorides, and other trace elements. The trace elements also playing a very important role in a contamination of a groundwater, and radionuclides dissolved of different gases, and some CODs and BODs. These are all, and some other biological components also there. Yeah, let us see the first one. It is the pH. The pH it is a very important parameter in this one. You see the water if it is acidic nature or basic nature. What it is acidic and what it is the basic. The acidic nature means the pH value. Suppose if it is six, less than 6 or 6.25, the water it has a acidic nature. And if you the natural water and the normal water it contains the pH it is the 7. And when you go into this is uh, alkaline. Alkaline means it is basis. In the basis, it is considering from the 7.5 above up to 14. Up to 14. Between this range, it is called as a basis or alkaline. And why it is, we can say that it's a natural water consists of hydrogen ions. It's combined with OH ions, but the process it's a dissociation is called hydrolysis. It's a take place in the whether the water hence it is contains the uncombined water, so that H plus ions and OH ions are individual. When the water it is coming in a acidic stage, that may be less than 7, less than 7. And when the ions that are which are excess than OH minus ions, it becomes an alkaline. So this is a ratios here. When it is a reverse in this case, for a neutral water, we know that is a pH is equal to 7. Neutral water always it's contain 7. and the concentration of H and H2 are both are equal. So that at the time definitely it has formed as H2O. It is in a neutral stage. pH value sometimes we taken measurement. The solvent power of a water for a various rock minerals. Just definitely, if you can see, it is a limestone areas particularly. In a limestone areas, maximum it's containing the carbon dioxide and carbonates. Because of in that one CaCO3 it will be there, so that is the reason. Ca if it is the dissociates, then automatically carbonates or carbon dioxide it will be formed. And groundwater generally it has a range 6.5 to H 8.25. That is well known. But in some other areas, the pH range it is showing the 6.2, 6.8.9. It is in near. It is in wherever the industry effluents or the impacting on the groundwater. Their areas it is showing the pH range normally in 6.2 to 6.6 sorry 6.2 to 8.9. Next, coming to the actually EC, but actually it was not mentioned in our textbook EC, electrical conductivity. The electrical conductivity, it is ions, how they are, what type of ions are present in that one, either which have the positive ions and the negative ions. And that means the protons and the electrons. So this, and it's depend on the formation of a salinity salts, how they will be formed. So here the conductance it's a very important. The ions conductance also playing the very important role when it is going to be dissolving the substances in different areas. So that in some areas we'll get a saline water because of saline water means more it is accumulating the sodium chlorides, accumulating the sodium chloride. So that's the salts it will be there. Here the conductivity is playing the important role. If it is the conductivity means the water salinity, if it is high, automatically we can say the conductivity is also it is a high. That is so that the salts it will be formed. And next coming to the total dissolved solids, it is called as a TDS. It is calling as a total dissolved solids. The bulk amount of a total dissolved solids may be inclusion of calcium, magnesium, sodium, bicarbonates, chlorides, sulfates, potassium, fluoride, and nitrates also. And if it is a minor part of a in a groundwater, actually, if it is a there is a some limit. Then normally, if you can see in our RO plants in our home, what it is this limit actually according to this is BIS standards, Bureau of Indian Standard. According to that, actually it should be below the 500 milligrams per liter. 500 milligrams per liter. If it is an increase, it is harm to our health. So that harpo plants must ensure it is a maintaining. We see that below the 500 500 milligrams per liter. It should be there. And sometimes actually that should be up to 250 milligrams per liter also. That is a normal and general requirement of the factor of that one. If it is that, it's very fine. The water is very good. Okay. Next, come into the yeah, based on these TDS content. The water it's uh, different types and different ranges. There are four types we can classify that. One it is of fresh water. The fresh water, the TDS, it is having the according to BIS maybe that is less than 1000 milligrams per liter. Brackish water it has 1000 to 10,000 milligrams per liter. Salty water it has 10,000 to up to 1 lakh. It's a brine water. It's above the 1 lakh of total dissolved solids. So that here we can use that the fresh water or normal water, it contains below the thousand. So that is reasonable and that is usable of the water. And total hardness. The total hardness it is soap destroying the power of a water. It's caused by the calcium and the magnesium. It's a combination of sometimes it's carbonates, bicarbonates, sulfates, and then nitrate constants also. The pH it is two types. Temporary it is hardness and permanent hardness. Temporary hardness we can remove. That is the carbonate. It's related with the carbonate hardness, and permanent hardness it's associated with the non-carbonate hardness. Hardness. So that this is we cannot remove. This is a permanent hardness. And the first one, carbonate hardness, it's associated with the carbonates and bicarbonates. It's consisting of a carbonates and bicarbonates, and generally it is associated carbon, calcium, magnesium, and potassium also. And when you come into this is next one, the pH classification type also mentioned. The type of classification, pH is a type of a classification in the groundwater. Soft water, we can see if it is a soft, the water it has a soft, we can consider that soft, that should be the pH, it should be less than 75 milligrams per liter. If it is a moderately hard, nearby the moderately hard, we can consider that is 75 to 150 milligrams per liter. If it is a hard, 150 to 300 milligrams per liter. If it is a very hard, if it is a very hard means above the 300 milligrams per liter. The thing when you come into this is the total hardness of a dissolve. So maximum it's consisting of a carbonates and bicarbonates in a water and expressed we can express it is a milligrams per liter. The pH more than 8.2 in water it has a carbonate ions, carbon ions, and the pH value it is controlled by a CO2. And actually it's consisting of there are different types of major ions like a calcium. It's the main maximum it is in all rocks which are having, but with the most of the constants of the rock it is a igneous, and it has a uh, I mean it has a presenting in a sedimentary formations also. And the principal source of calcium in groundwater are mineral like plagioclase, pyroxenes, and amphiboles. Among igneous and metamorphic rocks, like example for limestone, dolomite, gypsum, it's also consisting of the same. And if it is the presence of a CO3, the content of a calcium, it can be dissolved from the 20 to 100 milligrams per liter. The groundwater generally it's containing the calcium range that should be uh, 10 to 100 milligrams per liter. In the brain water, it's consisting of approximately it has 75,000 milligrams per liter. And also the same when you come into this is magnesium. The main source of the magnesium in the groundwater is coming from the dunites and pyroxenes. It is from igneous rocks and some volcanic rocks also like basaltic and talc, tremolites and amphiboles from metamorphic, dolomite sedimentary rocks and the clay materials also. They are if they will be dissolved in a seawater, definitely the magnesium it will be there. Generally, the concentration of magnesium it should be less than 50 milligrams per liter in a groundwater. But when it come into the brain waters, it has a almost 57,000 milligrams per liter. Uh, sodium bearing minerals like albite, plagioclase, clay minerals, evaporite, halite, and urban as well as the industrial waste, seawater, saline water, or the major source of sodium in a groundwater. It's a base on the exchange of calcium by sodium salts. It's a readily soluble and they tend to remain into the solution unless it's extracted during the evaporation. So that here the sodium content in the groundwater is a range is from 1 to 200 milligrams per liter. It is a permissible limit, and we cannot even coordinate water. Sometimes which is may having the 10,000 to 1 lakh milligrams per liter of a sodium. In generally in industrial areas and urban wastewater, definitely it is the value it is going to be increased because of other pollutants it will be added in this one, so that automatically the groundwater uh, position it will be going to contaminate. Potassium. The common source of potassium are present in potash feldspars, potash fertilizers also, felspathides, the micas and other clay minerals. Those are also having the potassium, and it is released into the very deeper level of groundwater. And also, it is abundant of sodium minerals in the earth crust. There are two factors are responsible for the phenomenon being the resistant of a potassium minerals, the composition by weathering and other fixation of potassium minerals in a clay formed due to the weathering in a ground weathering. Mm, So that's here what is happening automatically in a subsurface. These it is associated when it was associating with sodium and along with the other minerals, and it has a chance to easily dissociate with by the other factors. So it is going to be dissolved in the water due to that reason. Usually it contains 10 milligrams per liter. If it is the exceed of limit, it maximum it is 15 milligrams per liter. And some the brain water it contains about 1000 to uh, 25,000 milligrams per liter. Carbonates and bicarbonates. The primary source of carbonates and bicarbonates are HCO3 ions in a groundwater due to dissolvement of CO2 in a water. It is coming from the decaying of organic matter and organic soil materials. It is releasing into the water, and it is indicates the charged with CO to dissolve the carbonate minerals to give a HCO3. The pH of the water indicates the form in which CO2 is present. Not only that one, the maximum the limestone material, more and more it will be present in the water, and that's also releasing the more percentage of a CO3 in a water. And not only that one, if you can see into the seawater, the more corals it will be formed and they will live in the surface of a groundwater. Then there's all the release the more amount of a calcium carbonate into the water. So calcium it will be dissociated from this one. Then hydrogen it will be attaching or it is reacting with the carbonates, and then it will be formed as the bicarbonates also. There may be chance. And then what about the pH here? Then the pH it is suppose it is consisting of it 4.5, and HCO3 if it is present in that one that contains the 4.5 to 8.2, and this is a range when they were present in a water. And generally the carbonates does not exceed the 10 milligrams per liter, but in a water, right, in sodium, if it is high, it may up to 50 milligrams per liter. And groundwater normally contains HCO3 in the range of 250 to 500 milligrams per liter. Yeah, sorry for uh, interruption. I have some technical problem here, so that immediately it's left. Sorry for that cause. And next one is actually I'm speaking about the carbonates and bicarbonates. Yeah, it's also carbonates and bicarbonates. Also, generally it is in present in 10 milligrams per liter. That is the carbonates. And next, suppose if it is having the sodium, and it is going to up to 50 milligrams per liter. And normally HCO3, it's consisting of the range about 250 to 500 milligrams per liter. So that here, due to these reasons, the water, it is going to be chemically, it is getting the changes. And moreover, uh, along with this one, chlorides are also playing the very important role to contamination of a groundwater. Actually, it's releasing from the seeps of carbonates, the chloride materials. Like example for organic gases, and from the clay materials, urban and agriculture activities, and industrial waste materials. So these are all the releasing the same. So next, the concentration of chloride in a groundwater, it is commonly less than 10 milligrams per liter. If it is humid regions, and it's a more than 1000 milligrams per liter in arid regions. And next one, it is sulfates. Sulfate content, it is actually it should be present less than 300 milligrams per a liter in a groundwater. And as much as it's suppose if it is any influenced by the other mine drainages and other areas, if you can see in particularly in a brine areas, so that is go up to 2 lakh milligrams per a liter. And next one, it is a fluoride. Yeah, fluoride, it's very important mineral. And fluoride, apatite, hornblende, micas, uh, clays, and biotite mica. Clays by micas means biotite mica. And these are the major sources and major contributors for the fluoride in a groundwater. Actually, if it is the groundwater, the concentration of a fluoride, if it is in limited, that is very fine. But if it is increasing in a groundwater, so that is leads to the contamination of a groundwater. Actually, it should be present according to the BIS norms. It should be 1 milligrams per liter. If it is increasing, then it is going to be creating a contamination problems in that one. Suppose if it is a granitic terrain areas, that granites maybe if it has a gray granites. Gray granites means the composition maximum it has a biotite mica. So that from this is a biotite mica, it is a major source for the fluoride. Uh, and the water, it is interacting with the granitic formations. So that's what is happening. Slowly it is interacting and it is reacting with this granitic, and the fluoride, it will be forming slowly. And the fluoride, it is extracting by these water molecules, and it is dissolved in a water, and it is settled down in the water. And this is from the particularly apatite minerals, particularly from apatite minerals, where the apatite minerals is presented more. There definitely we have a more fluoritic zone or more fluoride water. Now the best example for Narkatpalli and surrounding areas, Chintapalli and surrounding areas, and in Anantapur district also it is recorded in high. It has a highly fluoritic in zones, and Prakasham district also it is also recording as a highly fluoritic zone. In Nalgonda areas, what I told you, that is Narkapalli, Chintapalli areas, and Devarkonda areas. These are the major areas for recorded of chloritic amount. And now coming to the trace elements. The trace elements like example for arsenic, barium, beryllium, bismuth, cadmium, chromium, cobalt, copper, lead, nickel, selenium, strontium, tin, titanium, and zinc. These are generally it is not exceeding the 1 milligrams per liter. If it is exceeding, and then the water it is going to be contaminated. Even though the higher content of a zinc, copper, lead can be it's a found, we can found nearby the mine areas, and the pH uh, it is having a low percentage. And similarly, zinc, arsenic, lead are which are associated with the ore bodies like where copper, chromium, lead, cadmium, arsenic, and uh, other materials which are all disposal from the industrial sources. And mainly the chief sources of silica in groundwaters are quartz, feldspar, feldspatite, amphiboles, pyroxenes. Wherever these are the majorly presented from that areas, we can get the more silica percentage in a groundwater. And generally, it's a contains about 1 to 30 milligrams per liter. That is a very common. And if it is go up to 1000 milligrams per liter, that is also not danger. And radionuclides. Some radionuclides, like example for uranium, thorium, radon, radium, these and are called the radionuclide elements, and which are the present very minute level. It's present into the very minute level. That generally, if it is a uranium in a present in a groundwater, the range maybe it is a 30 ppb. What 30 ppb means? That is maybe 0.00003 uh, um, milligrams per liter we can consider. 30 ppb means parts per billion. It is a parts per billion. So that if it is an increase, but suddenly if it is an increase, how it will be increased? The source from the host rocks or the water it is interacting in a deeper level by the dissolving of a uranium source rocks. So that from this source rocks, the uranium or uranium related elements which are released into the water, then it will be going to the contaminating. But it is the exceed limit, it is 30 ppb. Until unless if it is exceeded, then only we will get the contaminants. But otherwise, no worry about that. And some gases. The gases, most of the groundwaters, it's contain the dissolved gases which are derived from the natural sources. Those involved the in normal geochemical cycle of the groundwater. It is generally present in the atmospheric gases. Those are the carbon dioxide, oxygen, nitrogen, and other from the underground some biogeochemical process which are including the by the methane and hydrogen sulfide gases. These are also within the permissible limit, where actually they are not considered. We are not considered as harmful gases or contaminant gases. If it is an increase their permissible limit, which are harmful to the groundwater. And next one, it is a biological impurities or biological parameters. The bacteria and microorganisms, if they are present in your water in a very small amount, we cannot able to see our naked eye. So that, but these are actually, if it is within the permissible limit, which is also which is also not creating the any contamination. But if it is a increase, the percentage of organisms, then it is which are
damage the original quality of a water. Example for coliforms, which are present in the intestine of human beings and other warm-blooded animals, and it's transmitted to the facial matters. Although the coliforms, which are harmless, their presence in a groundwater, it is indicated the possibility of a presence of a pathogenic bacteria. As an indirect presence of organic matter in a water, that is a biologically oxygen demand BOD, it is called as a which is the amount of oxygen it is requires to cause the biological decomposition of organic matter and its waste. When oxidation it's complete and no oxygen is required, and the BOD is 0. Generally, groundwater is a free pathogenic organisms unless polluted by the surface drainage or industrial matter or any other organic composition with organisms. It will be decomposed in the soil. Then only it will be creating the contaminate sources. So these are the basic three parameters which are source for the resolving of a constitutions. Those are the physical parameters we have seen, chemical parameters we have seen, and the biological impurities also creating the problems in the crop. And environmental, when you come into this environmental problems, which the groundwater based, the first one, it is a human health. It's a human health. We are dependent on the domestic. We are dependent on the particularly on drinking of a water. And not only drinking and the water, it is useful for the domestic purpose. Uh, Domestic purpose. Suppose if it is undesirable parameters like some color, odor, and a taste, the temperature and temperature also. For a public water supply, the color and cobalt scale as in units we are calling that is should not exceed the 50, and we should be preferably less than 5. Less than 5, I'll tell you that is uh, the water. It's a generally we know that the pH it should be it should be it is in a normal or a neutral stage. That should be maybe 6.8 to around 7.8 up to that we should consider the water. In those water, it is considered as a natural or a neutral stage of a water. And the water, it's having the high TDS. If it is having the high TDS, it is not favorable. It is not favorable for our usage purpose. That should be the limit I told you according to the BIS, 500 milligrams per liter. Because of if it is increasing, maybe that water it is a local the taste you will get different. It is a salty taste, salty taste we will get, or a sour taste we will get. So that it is not suitable for our health, and the health will be damaged. So that these parameters definitely we need to take a consideration while we are drinking the water or we using for a domestic purpose. And some here mention the pH what it is highest or a desirable limit where maximum permissible limit. pH it is a 7 to 8.5, and TDS maximum it is a 500 to 1500 milligrams per liter. TH total hardness, if it is having the calcium carbonate, that should be we can consider 300 to 600 milligrams per liter. Calcium 75 milligrams per liter. Magnesium 30 milligrams per liter. Sodium 200 milligrams per liter. Calcium chlorides 250 milligrams per liter. Sulfates 150 milligrams per liter. Fluoride 0.6. It is a desirable limit, and if it is a maximum, the permissible limit is 1.5 milligrams per liter. In your textbook, it is mentioned 1.2. Okay, but 1.5 it is we can consider. Nitrates, it's a 45 milligrams per liter. Iron 0.3 or 1, we can consider. Zinc 5 grams 5 grams milligrams per liter. Up to we should consider up to 15 milligrams per liter. arsenic 0.05, hydrogen Hg, that is 0.001 milligrams per liter, cadmium 0.01, and others, barium, argentinum, these are all up to 0.05 to 1 milligrams per liter. We can consider that. And again, there are some health diseases also due to this chemical constituents. If it is available, if it is mixed, or if it is dissolved in a water, we will get diseases. Arsenic, it's due to this one, dark skin, hair loss, barium, thyroid disease, boron, brain disease and fever, cadmium, hypertension, some other kidney related disease we will get, cobalt, iron, lead, fibrosis, lungs, anemia, and the disease we'll get from this one. Due to this is a manganese deficiency, we'll get a tremor and fever. Mercury, we'll get the loss of memory. Molybdenum, anemia and liver disease. Nickel, nasal irritation, abdomen cancer, and dermatitis diseases we'll get. From zinc, fever, brain involvement, and gastroenteritis, like these diseases we'll get if these chemicals which are present in a water above the permissible limit. And treatment of a groundwater. Now we can treat the groundwater. Yeah, the water it is required to everyone in all the purposes, in all the sectors. So that the water it should be potable. Yeah, yes. First part we have to see. We'll remove all the physical above the permissible limits of the physical and chemical constituents from a water, and there are some various processes are there for that one. Sedimentation. In the first stage of a treatment, the water it should be filtered, and the water it should be filtered means the water, and it is includes the provision of the sedimentation tanks, and settling the tanks and the classifiers which are having the water tank, the water, if you can send to that one, the tanks which are remove the inorganic impurities, and it's making the waters to fit for the next process of a filtration. And the next one, it is a coagulation. It is to make the particular of a big size, adding the certain chemicals like aluminum sulfates, chlorinated coppers, ferrous sulfate, and lime, magnesium carbonate, polyelectrolytes, and sodium aluminate. These are all the known as coagulants of water, and these coagulants make it the impurities in your water and convert them into the settleable size. Next process it is a filtration. The filtration forms the most important stage in the purification of a water. It's usually consisting of allowing a water to pass through the thick layer of a sand. Yes, actually it has a sand layer. Through the one, the water it should be transmit or the pass it. Then when it is moving through this is filters, then the suspend material or colloidal impurities it is removed, and it should be altered by the chemical characteristics. The water it is reduced the amount of bacteria material in that one, and this is an infection. When water leaves the filter point, it is still found so it's contained some of the impurities such as bacteria, dissolved inorganic salts, salts, color, odor, taste, and iron manganese. This process it is to prevent contamination of the water during the transit from the treatment plant place to where it is a consumption. And water softening. The water softening again it is depend on the pH of a water, the total hardness of a water, and it has two methods. One, it is a boiling or adding the lime, and the second one, it is a boiling lime soda or adding a lime soda. The first procedure, it is applied to remove the temporary hardness, and when second procedure, it is remove the permanent hardness. And these two methods are very important when the water it is converting into the when hard to soft water. And this is about the water quality. It's a groundwater quality. And next one, it is water pollution. Yeah, we'll discuss tomorrow the water pollution. I'm stopping here.